Okay, we are now at the last stage in our discussion on limiting factors where there are two aspects which have to be discussed. One is a concept called slack, and the other is a concept called shadow price. Okay, now please understand that these are topics where MCQs will frequently be tested. Section A may be aayega, section B may be aayega. In the past, it has been tested on many occasions. ठीक है. अब when you think of the word slack, it's not just a word that you will come across in costing, but in real life, in day-to-day conversations also, we use the word slack very frequently. If I say, why are you slacking? That means, why are you not putting in the effort? That means you have the capacity to do this much, but you are only doing this much. You are slacking means you are not working at your full potential. You are somewhere lacking. You are not giving in what you are supposed to do. That is when I say, Junaid, why are you slacking in your effort? That means, Junaid, you are not working at your full capacity. You are underutilized. You are wasting time, which means you have free time. So when we are discussing constraints, slack is the amount by which a resource is underutilized. That is, a slack occurs when the maximum availability of a resource is not used. I have 200 hours of labor time. I am using only 180 hours. There is a 20 hours ka slack. Okay. Now, slack, say for example, there are two products that I am making, product X and product Y. I am making 10 units of X and I am making 5 units of Y. Okay. For me, the labor time available is 200 and the machine time available is 250. This is a hypothetical situation. Now, 1 unit of X needs 10 hours of labor time and 1 unit of Y needs 20 hours of labor time. So, 10 into 10 plus 5 into 20, 200 hours. That means labor time is fully utilized. For machine time, we need 12 hours of X and 10 hours of Y. So 12 into 10 plus 5 into 10. That makes it 170 hours. Available machine time is 250. That means I have more time available, but I'm utilizing less time. So I am utilizing 170, but available time is 250 hours. Utilized is less than available, and this is a situation where you say that there is a slack. Now, graphically speaking, it will occur when the optimum point does not fall on a given resource line. Now, how does that work? Let me show you. Let's make a simple graph and understand where exactly does the optimum solution lie and how does a slack reflect on a graph paper. Okay. Now this is your typical XY axis, and I'm going to draw three lines here which are basically indicative of three different constraints. Okay. This is my constraint 1. Let us assume that this has a less than or equal to constraint. Less than or equal to means you either go on the left or you have to go down. I would say this is my constraint 1. Let's draw another line which stands for constraint 2. This is constraint 2. Okay. And let's draw one more line which basically indicates constraint 3. Let me make it a little more bold than the usual lines. Okay. अभी ऑब्जर्व दिस, देखिए दिस इज कंस्ट्रेंट 3. Me call it C2. Let me call this C3. There isn't enough space. ठीक है. अब if you observe, all these three lines have a less than or equal to constraint. ठीक है. Less than or equal to constraint मतलब जो भी होगा वो left side में होगा. Now if I were to draw the feasible region, how would I draw the feasible region? The feasible region is on the left. So this is my feasible region. ठीक है. Correct. This happens to be my feasible region. Everything on the left. So this area. This is my feasible region. Okay. Up. When I say that I want to uh, decide where exactly does my answer lie in a linear programming problem, my answer always lies on the corner points. That is my corner point theorem कि मेरा जो भी solution होगा, my optimum solution will always lie on the corner point. तो zero C, zero A, अरे हाँ, जीरो ए बी सी डी ऐसा है मेरा feasible region. जीरो ए बी, यहां पे आ जाएगा सी, एंड दिस इज माई डी. दिस इज माई feasible region. इसको लेफ्ट में शिफ्ट करते हैं. जीरो ए बी सी डी, दिस इज माई feasible region. अब the answer to my linear programming problem lies on the corner points, which means either 0 या फिर A या फिर B और C और D. यूजुअली ये तो कभी होगा नहीं. जीरो, that is 0 0 coordinates means you are not producing product X, you are not producing product Y. That can never be the answer. Say, let us assume that your answer is point B. ठीक है, आपका आंसर है point B. Now point B, if you carefully observe, is an intersection of which two lines? If I say that point B is my optimal solution, ठीक है, point B is my optimal solution. इसको इधर देखो. It is intersection point of point B is an intersection point of which two lines? Observe carefully. C2 and C3 का intersection है. ठीक है. Point B is an intersection of C2 and C3. This is C1. अब ये जो point B है, this is at the intersection of C2 and C3. Okay, and it is very much our feasible region. Why? See, we had a less than or equal to constraint. मतलब answer was supposed to lie on the left hand side of this line. Okay, answer was supposed to lie on the left hand side of this line. अब ये point B lies on the left hand side of this line, so we are okay. इसमें we don't have any problem. So D C B A, 0 A B C D is my feasible region. Okay, now this lies on the left hand side, so point B lies on the left hand side. We are okay, which means solution is proper. But अगर आप देखो तो line C1, what does line C1? Maybe line C1 is say machine hours. Okay, line C2 is say for example, sorry, line C3 is labor hours and line C2 is say for material. Okay, so C1 is machine hour, C2 is material, C3 is labor hour. The answer lies at the intersection of these two lines. Okay, now it's on the left hand side. It lies on the intersection of these two lines. Solution तो बराबर है, but line C1 is above this particular point. यहाँ पे देखो, you will see some area which is point B is here, and ये देखो line C1 is above this line. At the point of intersection, that means there is some unutilized resource. ठीक है, there are machine hours. ये जो point B है, इस पे machine hours इतना available है, but utilize only this much is happening because this is the optimum level of production. So when I have my optimum level of production, there is still some unutilized machine hours. So what they were trying to say here is that graphically speaking, it will occur where the optimum point does not fall on a given resource line. It has to fall below the given resource line. ठीक है, इट इज नॉट ऑन लाइन C1, इट इज बिलो लाइन C1. वो अनयूटिलाइज स्पेस आपको ग्राफ में दिखेगा. ठीक है, देयर विल बी नो स्लैक फॉर दीज रिसोर्सेस. व्हाई विल देयर बी नो स्लैक? बिकॉज आई मैक्सिमम यूटिलाइजेशन तो हुआ ही नहीं है ना. स्लैक इज व्हेन मैक्सिमम यूटिलाइजेशन हैज नॉट हैपेंड. द रिसोर्स इज अंडर यूटिलाइज्ड. यहाँ पे रिसोर्स अंडर यूटिलाइज्ड है, तो दिस रीजन इज ग्राफिकली माई स्लैक. Okay, a full utilization of that resource has not happened. ठीक है, the optimal solution will occur where two critical constraint lines cross. There will be no slack for these lines. अब देखो, these two lines, this point is on the line. The point of optimum solution is on line C2 and C3. That means resource indicated by C2, that is material, and resource indicated by line C3, that is labor, are fully used up. The point lies on the line, उनका full utilization हो गया, but it lies below C1. Point B is not on C1, but it lies below C1. That means C1 is not fully used up. ठीक है, C1 is not fully used up. C1 has slack. ठीक है, whatever that resource is, that is basically यहाँ पे machine hours are not fully used up. Slack is important for two reasons. For critical constraints, zero slack, getting additional units of these scarce resources will allow the optimal solution to be improved. Similarly, if another department wants these resources, then it will result in lower contribution. अब किसी और डिपार्टमेंट को या किसी और एक्टिविटी के लिए इफ यू नीड द रिसोर्स C1, यू कैन स्ट्रेट अवे टेक इट फ्रॉम देयर. अब यहाँ पे अनयूज्ड पड़ा है तो वो अनयूज्ड मशीन टाइम यूज कर लो. You don't have to pay anything extra for a new machine. So this is what graphically a slack stands for. To determine how much of this makes the scarce resource worth to the business, we'll see what is a shadow price. ठीक है, shadow price का concept थोड़ा सा बाद में देखते हैं. पहले इस पे एक क्वेश्चन करेंगे. ठीक है, एक बार have a look at the theoretical aspect, just quickly go through it. ठीक है, चलो एक क्वेश्चन देखते हैं. लेट्स सी हाउ these questions are asked. This is question 1 of limiting factors. Okay, that we had done earlier. What I'll do is I'll bring in a copy of that question here right next to this so that आपको पता रहे कि विच क्वेश्चन आई एम रेफरिंग टू। दिस इज बेस डेटा फॉर क्वेश्चन वन। ठीक है, where we had defined one, two, three constraints, two non-negativity constraints, and one constraint about the number of units. Okay. So, refer question one of limiting factors. This is base data. Or here I'll write down refer base data for question one tab. आपको भी clear हो जाएगा. Refer base data for question one tab. ठीक है. In the earlier questions, we solved the following problem where the objective function we had was to maximize contribution C equal to 4x plus 8y, subject to department C का time 8x plus 10y less than or equal to 11,000, department D का time 4x plus 10y less than or equal to 9,000, department E का time 12x plus 6y less than or equal to 12,000. Non-negativity constraint 0 is less than x and y both. The optimal solution x equal to 625, y equal to 600 was found at the point of intersection of department C line and department D line. ठीक है. What was the optimal solution in this case? हमने पूरा question solve किया था 625 of A and 600 of B. 625 of A and 600 of B was the optimal solution. ठीक है. Now when the optimal solution lies, where was this optimal solution? 600 of this and 625 somewhere here. ठीक है. ये था मेरा optimal solution. This is my optimal solution, this specific point. Now if you observe यहाँ पे there are too many lines passing through, थोड़ा इसको magnify करते हैं. If you observe this point R, which is 625 comma 600, which is my optimal solution, this point lies on the intersection of ये orange line and ये blue line. ठीक है. It lies on the intersection of orange line and blue line. Orange line is y equal to 600. Blue line कौन सा है? Blue line is 8x plus 10y equal to 11,000. Now we saw this a minute ago that at the point of intersection, वो दो resources are fully utilized, which means this particular resource, what was line blue for? Line blue was डिपार्टमेंट सी का मशीनिंग टाइम. ठीक है. सो डिपार्टमेंट सी का मशीनिंग टाइम इज फुल्ली यूज्ड अप एंड maximum possible demand has been reached, but department D ka machining time and department E ka machining time has not been fully used up. This point of intersection is below the purple line, is below this green line also. It's below both the lines. That means the resources indicated by these two lines have not been fully used up. ठीक है. So product Y constraint is a critical constraint with no slack. Department C time is a critical constraint with no slack. Department C का resource is indicated by blue line. Point of the optimal solution lies on the blue line, which means department C का जो भी resource था that has been fully used up. But it lies below the purple line and it lies below the green line, which means itna capacity hai, but I'm using only this much. This is indicative of the fact that there is a slack. For department D, actual amount of time used is 4x plus 10y, which is 4 into 625 plus 10 into 600, which is 8,500. This is the question we did on the first day of the discussion of limiting factors. कितना है टाइम? 8,500. डिपार्टमेंट डी का अवेलेबिलिटी कितना था? डिपार्टमेंट डी का अवेलेबिलिटी था 9,000. देयर इज अ स्लैक ऑफ 500 hours. And in department E, what was, how did you define the constraint? 12x plus 6y, which was 12 into 625 plus 6 into 600, 625 units of x and 600 units of y. आपका आया 11,100 as the total number of hours actually used. But आपका जो अवेलेबल आवर्स था वो अवेलेबल आवर्स 12,000 था. यू हैड मोर टाइम, यू यूटिलाइज लेस टाइम. देर इज स्टिल अनयूटिलाइज्ड रिसोर्स कैपेसिटी, एंड दैट अनयूटिलाइज्ड रिसोर्स कैपेसिटी इज कॉल्ड स्लैक. ठीक है. वो स्लैक, नाउ यू नो ग्राफिकली हाउ डज द स्लैक लुक. इसमें we had seen, and we also saw in the base data for question 1, the point has to lie below the optimal solution. So the optimal solution point lies on the two lines where they intersect, but there is another line which is above this particular line. ठीक है. Optimum utilization of the resources and optimum production happens at point B, but this is below line C1. That means C1 में अभी भी there is unutilized capacity, and that unutilized capacity is your slack. Okay, so have a proper look at this one. Go through this once and tell me if you have any questions on this whatsoever.